This is a Mitsubishi mini-split air conditioner 1-ton unit circuit board. I will explain where and how much voltage is present at different points, with a special focus on how the power supply works and how the switching operates. The PCB of the unit I currently have is divided into 3 parts. First, there is the main PCB, which is known as the control PCB. After that, there is the switching PCB, and finally, there is the display PCB. Now, first of all, let me explain that the PCB I have right now receives the main power supply, which comes to the indoor unit. From there, switching occurs, and through a switching relay, the supply is sent to the outdoor unit. This is how the system powers on the outdoor unit. So, if the outdoor unit is not turning on, meaning the supply is reaching the switching relay but not passing through it, then it could be an issue with the wiring. However, if the switching relay itself is not turning on, then I will explain the next steps to you. Now, let's talk about when you've connected the supply correctly. You'll notice that there are 2 fuses. One is hidden, and the other is visible. These fuses are 3.5 amps each. If either of these fuses fails, neither the indoor nor the outdoor unit will work. So you should check both of these fuses to ensure they are functioning properly. If the fuses are perfectly fine, but the issue persists, then we need to check the power supply. If switching is not happening, we should investigate the power supply to identify where the issue lies. Now, let's understand the switching relay PCB. Here, you can see that a capacitor is installed on the PCB. This capacitor is connected to the main supply so that when the power enters, it goes through the capacitor before proceeding to the power supply. Along with it, there is a ZNR, which acts as a safety device. If the voltage rises above 250 volts, the Zener diode will short circuit, causing the fuse to burn out. Along with it, there is a resistor and a diode. These components are used for communication wires. The communication takes place through this diode and resistor. Now, let's talk about these wires. Some wires are entering the PCB, while others are returning outward. So let's understand how these connections work and their role in the system. The connector is numbered from 1 to 10. The wire at position 1 is the phase wire, which supplies power to the PCB. It serves as the main power input for the PCB. Next, the second and third wires are empty. The fourth wire is the neutral wire, which is coming into the PCB. The fifth wire is also empty. The sixth wire is the communication wire, which comes out of the PCB and facilitates communication between the indoor and outdoor units. Along with this, 2 points are empty. The 9th and 10th wires are used to switch on the relay. These points are marked as positive and negative, but it's not yet confirmed which one is positive and which one is negative. I will explain this further as we move ahead. If the switching part is working perfectly, the electricity is flowing correctly, and the fuses are intact, then the power can enter the power PCB. Along with this, the main control system is also located within this PCB. The first entry point on the power PCB is the line filter. Here, the electricity enters the line filter, and we should get 220 AC volts at both of its points. Next, on the neutral side, you'll see a resistor connected. This is a 5-watt, 4.7-ohm power resistor. The power resistor is critical for managing inrush current in the indoor PCB. Ensuring a smooth and controlled power-on process protects the system from damage, enhances reliability, and contributes to the overall efficiency of the air conditioner. After this, the system directly enters the rectification stage. Here, instead of using a rectifier module, individual diodes are used to form a bridge rectifier. You can see the 4 diodes on the PCB. These diodes convert the AC power into DC power. As soon as the power is converted to DC, it moves forward to a capacitor. This capacitor is a 47 microfarad, 450 volt capacitor, which helps in smoothing the DC voltage. As soon as the electricity enters this stage, we should have around 320 volts DC across both points. A voltage of up to 310 volts is also acceptable for proper operation. Moving forward, you will see a component that looks like a diode, but it's called TVS, transient voltage suppressor, which absorbs and dissipates sudden voltage spikes, protecting sensitive components in the board, like microcontrollers, ICs, and power MOSFETs. After that, you'll see capacitors used for filtering. There is also a component labeled L1, which is an inductor. It protects the circuit in case of overcurrent. You may also notice another inductor labeled L11. Alongside this, there is a switching IC with number MIP0244SD. If there is an issue with this IC, the PCB will not power on at all. Now, I will provide a complete explanation of how its chopper circuit works and how the entire system functions. But before getting to it, let me tell you that if the electric line is reaching up to the filter and the overvoltage reactor and resistance are also perfectly fine, but despite this, the PCB is still not working, then the issue could be in its rectifier system. In rectification, you should check the diodes. If even one of the diodes is faulty, or if all the diodes are damaged, then the AC voltage will not be converted to DC, and the system will not function. After this, if the rectification system is perfectly fine, but the system still isn't generating 320 volts, then the issue could be in the filtering capacitor, and it might be faulty. If this capacitor is completely faulty, it will show 0 voltage at this point. In such a case, the capacitor needs to be replaced. Alternatively, if the small capacitor, possibly a TVS or transient voltage suppressor, is damaged due to a short circuit, it will also need to be replaced. Next, let's talk about its switching IC. If we look at pin number 6, it is the drain pin. The drain is typically used to operate the chopper, and it serves as the final point in the circuit. What happens is that when we supply electricity to the system, the IC turns on the power for a few milliseconds. During this time, it directly activates the system without checking any other points. The checking process starts only after these milliseconds have passed. At this stage, the switching IC begins to search for feedback. So the feedback comes from the optocoupler. Here, I will share some points where the voltages should be present. If the voltages are not present at these points, then it becomes necessary to check the system. Here, there are 2 points connected to the chopper. We should get 320 volts at this point. If 320 volts is not present here, it means the switching IC did not operate properly, and as a result, no further voltages will be generated. So first, we need to check the drain and source to see if we are getting voltages. If the voltage is not coming at the drain, then you need to check the source. If the voltages are correct up to this point, it means the drain has not been switched on, which indicates that the switching IC has not turned it on. In this case, the issue could be that the switching IC itself is faulty. But despite this, there could still be some other faulty components. Let me show you. Here, a diode is placed. The diode number is 115, and 18 volts should be present here. In addition to this, there is also a capacitor connected in parallel with the diode. So, you should get 18 volts at this point as well. If 18 volts is not present here, it means the chopper could be short-circuited. When the chopper is short-circuited, it will not provide the 18 volts at this point. Additionally, the capacitor number C112 should have 5 volts on both its negative and positive terminals. This 5 volts will be provided by the chopper as feedback, and it will send this to the common point. When this happens, the switching IC will start operating, and it will open the voltages from the source to the drain, allowing the chopper to start working. There is a voltage detector here. The function of the voltage detector is that when the switching IC needs to open the voltages for a few seconds, the voltage detector will detect that voltage. After that, the voltage detector will pass the voltages to the optocoupler, and then feedback will be generated from the optocoupler. This feedback will then go to the switching IC. So, if the voltage detector is faulty, this can also cause an issue. Now there is one more very important component. If it fails, the entire system will stop working. That component is this capacitor. This capacitor is used to generate the negative point. If this capacitor fails, the negative voltage will not be generated, and the circuit will not function. As a result, the entire system will stop working. That's why it is important to check this capacitor as well. If it's faulty, it's best to replace it directly. In this way, the system can be fixed and the chopper will start working properly. In addition to this, if we look here, we can see 5 pins, and this is the high side. On its low side, only 12 volts is being generated here, and the chopper allows you to obtain multiple voltages. You can get as many as you want in DC to DC conversion. In the same way, here only 12 volts is being generated. But there is one more thing to understand here. If we look at the negative side, this negative voltage is being generated from here. After this, if we check the positive side, you'll notice that when you check the anode side of the diode, you won't find any voltage. However, as soon as you check the cathode side, you will get 12 volts. This is because of the filtering capacitor. A filtering capacitor is placed here to ensure that the generated voltages are smooth moving forward. Since you won't see any voltage behind this, you'll see 12 volts here. And this 12 volt is used for different functions, such as keeping the switching relay on. Additionally, it's used to power the swings and other components. So, all these tasks are powered by the 12 volts. So now this 12 volt is sent here. As you can see, we have a voltage regulator, which is a 5 volt voltage regulator. Its function is to take in the 12 volt supply, where the center is ground, and the third pin provides the 5 volts output. These 5 volts are then sent to the microcontroller and other small components to operate them. So along with this, there is an IC, and it is a triac. The triac is used to control the AC fan blower motor. It plays a critical role in regulating the fan blower speed by controlling the AC power delivered to the motor. Here you can see 2 capacitors, a resistor, and the triac, all placed for this specific purpose. The capacitors are filtering capacitors, and the resistor here is used as a fuse. It's a 47 ohm resistor. If there's any issue with the fan or a short circuit, this resistor will burn out, protecting the fan motor from damage. In addition to this, there is also an inductor placed here because a positive supply comes in. An inductor is essential for ensuring stable, efficient, and reliable operation by mitigating noise, managing current transients, and protecting the triac and the load. After this, let me explain that here you can see some motors attached, and there's an eye sensor. This sensor is a motion detector. If there aren't many people moving in the room, the sensor detects this and slows down the cooling due to the room being empty. This helps save energy by adjusting the system's performance based on the room's occupancy. However, if there are more people in the room, the sensor will operate according to that. This is a very useful function. To operate it, there is a 12-volt motor installed here. The 12-volt generated earlier is used to operate this motor. After that, the same 12 volts is used to operate all the swings in the system as well. So, this motor has several configurations, which is why a ULN 2003 type IC is used here. However, its number is slightly different, but it performs the same function. It is a 14-pin Darlington Array, and it is used to operate the motor. This IC switches the motor to different positions as required. But what switches this Darlington Array? It is directly controlled by the microcontroller. The microcontroller sends signals to the Darlington Array, and in turn, it operates at high voltages to control the motor. All the motors in this system receive direct positive voltage. The Darlington Array controls them by connecting the negative point to the motor. When the negative point is connected, the circuit is completed, and this allows the motor to start functioning. Similarly, if we talk about the switching relay, it works in the same way. The 9th wire serves as the positive supply, which is directly connected to the switching relay. However, the negative point is not directly connected. To connect it, you can see that I have checked the wire and it is going inside the Darlington Array. This IC is similar to a ULN 2003 type IC. The negative point is switched on from here to activate the switching relay. The Darlington Array is controlled by the microcontroller. The microcontroller sends signals to the array, and only then does it turn on the relay. Otherwise, it remains off. If the Darlington Array itself becomes faulty, it can cause an issue. Similarly, if the microcontroller fails to send the on signal, the relay will not activate, indicating that the microcontroller might be faulty. In most cases, the high side of the microcontroller is the one that gets damaged. There are 2 pipe coil sensors and 1 room sensor. We need to have 5 volts on these thermistors. If 5 volts are not present, the system will not function properly, and an error will be displayed on the screen. In addition, the communication system between the indoor and outdoor units is essential for proper operation. This communication is established using 3 optocouplers. Additionally, there is an EEPROM install here, which also requires 5 volts to operate. These 5 volts must be present on its pins. Only then will it function properly. This is how the entire system works. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.